OX and OY are position vectors relative to the origin. Given the points X and Y, write OX and OY as column vectors. Now the coordinates of X is 13, -9, and the coordinates of Y is -7 and 24. And they want us to write column vectors, and they want us to write OX and OY as column vectors. Now, in order to write OX as a column vector, we're simply going to take the coordinates of X, and instead of writing it horizontally, we're going to write it vertically. So we put 13 on top and -9 at the bottom. So that means that the column vector OX is equal to 13 and -9. Next, we have to write OY as a column vector. And so we're just going to take the coordinates of Y, and instead of writing it horizontally, we're going to write it vertically. So we put -7 on top, and we put 24 at the bottom. All right, so we write it vertically. Okay, next, we have to express XY as a column vector. And so XY is equal to XO plus OY. And it makes sense because you can imagine it like this, right? So you can think of it like this. Imagine that you have X right here, right? And O is the origin. So imagine you have the origin here. And you have Y. Imagine that you have Y here, right? And our goal is to go from X to Y. So in order to get from X to Y, we have to go from X to O first. That's why we have XO here. And then we're going to go from O to Y. And that's why we have OY. And if we do that, then we'll go from that. And if we actually follow this path, then we actually would end up at Y, starting from X, but ending at Y. And so that means that XY is actually equal to XO first, then OY. All right, and that makes sense. And so what we're going to do here is we notice that we have to write XY as a column vector. We know what OY is, and we found it in the previous question. We know that OY is equal to -7, 24, but we do not know what XO is, right? We don't know what XO is. What we do know is we know what OX is, but we don't know what XO is. But what we can do is we just could switch the letters because this is XO. We know what OX is. So all we need to do is switch the letters. So we're gonna switch the letters because we know what OX is. And if we can have OX, then we could substitute OX. And so that would be helpful. So instead of writing OXO, I'm gonna switch the letters from XO and I'm gonna switch it to OX because we have what OX is as a column vector. But there's a penalty for switching the letters. If you're switching the letters, the penalty for switching the letters is you have to put this negative sign. So in order for these two to be equal, you have to put the negative sign. So it is possible for you to switch the letters. That is fine, no problem with that. But you have to pay the penalty, and the penalty is you have to add on a negative sign in front of this. And so we have that XY is equal to -OX plus OY. And so we substitute. So what is OX? OX is 13 and -9. And what is OY? OY is -7, 24. Now we multiply each term in this vector by -1. So we have -1 multiplied by 13, and that gives us -13. And we have a -1 multiplied by -9, which gives us +9. And so we have a -7, which is here, and we have +24, which is here. And so we have that XY is equal to this factor. And so XY is equal to this factor plus this factor. And so we have to add these two vectors. We have a -13 plus -7, and -13 plus -7 is -20. And then we have 9 plus 24, and 9 plus 24 is definitely 33. So that means that XY expressed as a column vector is -20 and 33. Next, it says that they want us to calculate the magnitude of OY. Now, what is OY? OY is simply -7 and 24 written as a column vector, but they want the magnitude of OY. So if we want to figure out the magnitude of a column vector that has two entries, what we're going to do with the first component is we square the first component. Then we take the second component and we square it as well. Then we add these two answers. So we find the sum, and we're going to take that sum and we're going to take the square root of that. So in general, if you're trying to find the magnitude of a column vector that has two components, you square the first component, you square the second component, you add those two, and then you take the square root of it. And so OY, the vector OY is equal to -7, 24. And we calculate the magnitude of OY in the following manner. We say that the magnitude of OY is equal to -7 squared plus 24 squared. And -7 squared is equal to 49. And 24 squared is equal to 576. And so what do we have? We have 49 plus 576. And 49 plus 576 is equal to 625. So that means that the magnitude of OY is equal to the square root of 625. And the square root of 625 is definitely 25. And so that means that the magnitude of OY is equal to 25. And that's the answer to this question.